Welcome again to Let's Talk Advanced Chemistry. Let's Talk Chem 2 with Pastor Dan. And we're looking, if you look over here to the your left, my right, we're looking at light emissions, and we talked about that in terms of electron configurations and all those kinds of things. When we do these problems, just a quick reminder, if you have any issues with them, you don't need help, my email is ltswpd@gmail.com. Email me so we can get together, we can talk, tutoring session, whatever works, in that way. Also, if you don't remember, because again, this is a review from Chem 1, all my stuff on emissions are on Chem 1 days 39 through 41, so that's where you can find all this information. All right, so let's get started. I'm going to have one problem here because basically these are just different variations of how, and this is the toughest kind of problem that I can give you. So we're going to start with the problem, what is the wavelength of an emission if the energy is 2.1179 times 10 to the minus 19th joules. So basically, if we determine the energy of that wave, we can find out the wavelength of that light was. So we start with our first equation. What's new? If you remember from Chem 1, new is equal to C over lambda, where the other equation we have is E equals H, little hat on it, nu. So what are these values here? Well, that funny pregnant V is called nu. It means frequency. Frequency is expressed in hertz. Now, hertz means per second. So when we work with it, it's per second. When we answer it and give it as a value, it's hertz, HC. All right, C is the speed of light in a vacuum. It's 2.99 but times 10 to the 8th, but to make it easier, you're just gonna call 3 times 10 to the 8th meters per second. And then upside down Y, that's called lambda. Lambda means wavelength expressed in nanometers. 1 meter is 1 times 10 to the 9th nanometers. Now the other equation then, E is energy. It's expressed in joules. Okay, and that H with a hat, we call that Planck's constant, not Planck. Planck's got corrected quite sternly by a former co-worker at a different district because I said it wrong. Planck's constant is 6.63 times 10 to the negative 34th joule seconds. All right, so let's get started with this problem. What is wavelength of emission of energy? 2.1179 times 10 to the negative 19th joules. Joules is energy, remember, so we're going to use the equation E equals H times nu. Now, the only value we don't know there, the one that we have to use to find wavelength is nu. So we're going to move H to the opposite side. E is opposite from nu, so it stays on top. Planck's constant goes on the bottom. Plug our values in. 2.1179 times 10 to the 19th joules and 6.63 times 10 to the negative 34th joule seconds. Now we include our units there, so our units cross out. Joules cross out. Take our handy dandy Joe Dandy calculator, do your scientific notations, and we get 3.1944 times 10 to the 14th per second. Now remember, that's 5 sig figs here. This is a constant, 6.63 times 10 minus 34th, so it's infinitely significant. A 5, infinite, smallest number is 5. The number should always be around 14, 13, maybe 15, the exponent there, so that way you know you're in the right ballpark. All right, now that's new, that's not what I'm asking for. I didn't ask for frequency, so I'm not gonna express it in hertz. I'm gonna keep it in per second when you use the equation. The equation nu is equal to C over lambda. We have nu. We want lambda, so we're going to bring lambda up and bring nu down. Swap partners. We're going to get lambda is equal to C divided by nu. Plug our values into there. So remember, we said that C is 3 times 10 to the 8th meters per second. And we found out that nu is 3.1944 times 10 to the 14th per second. And we're going to want this in nanometers. So 1 times 10 to the 9th nanometers is 1 meter. Meters cross out. Now, if you want to be quicker about it, you can just simply, and you know you're going to get the nanometers anyway, we just say 3 times 10 to the 17th nanometers per second, and that way you can just work with that value, make it quicker to use that. Use our 3.1944 times 10 to the 14th per second. Our seconds cross out. Remember, 3 times 10 to the 17th nanometers is a constant, infinitely significant, so we have to wear sig figs there. 3.1944 is 5 sig figs, so we have 5 sig figs as our answer. Plug your calculator in. Work it through. Here we go. Answer should be 9.39.14 nanometers. That's it. Hopefully not too bad. Take care. God bless. Bye.